area, the cross-section cut from the ellipsoid x squared plus y squared over 49 plus z squared over 64 equals 1, and the plane z equals d as a function of d. So in other words, we're just replacing z with d because we're doing it there. And then it's saying that an ellipse, since we're only in the 2 dimensions, we're now an ellipse, with semi-axes a and b has a area of pi ab. So we have to figure out what a and b are in our regular ellipse formula. So what I'm going to do here is I'm going to start by rewriting this. This is x squared plus y squared over 49 plus now d squared over 64 equals 1. Now what I'm going to do is I want to just have this part, which is the regular ellipse, and then I want a 1 over here. So first I'm going to move this over here. So I have x squared plus y squared over 49. So then I get 1 minus d squared over 64. Now I'm going to clean this up a little bit. X squared plus y squared over 49 equals, okay, 64 minus d squared over 64. Now I need this to be 1, right? So what do? You divide by the same thing. So I want to divide this by 64 minus d squared over 64, this and this. So then, now the reason, normally, I'd say multiply by the reciprocal, but I actually want to divide, and the reason is I'm going to write this out here, hopefully semi-neatly, okay, plus this is going to be the y squared, and then here I'm going to have the 49 still, and then 64 minus d squared over 64, and then this equals 1, right? But why did I do it this way? Because with an ellipse, I want these by themselves, right? Because then this here, this is my A and my B, and I need that A and B for the formula. Now A and B, if you remember from your ellipse, is the square root of this. This is the square root of 64 minus d squared over 64, and this is the square root of 49, 64 minus d squared over 64. So this, I can simplify this down a little bit. I have the square root of 64 minus d squared over 8. And then this is going to be 7/8 64 minus d squared. Okay, then the formula that they gave us was pi ab. So then this is going to be 64 minus d squared, 8 times 7, 64 minus d squared over 8. And then we've got the pi out there. Okay, so let's clean this up a little bit. So I have a 7 pi and then 64 minus d squared, because the two radicals cancel each other out, all over 64. So then this here is my answer. So let's go put this in here. So this is 7 pi 64 minus d squared, and then this whole thing is over 64. Okay, now the next step is we want to use perpendicular slices to find the volume. So we are going to integrate, okay, with regards to z. So now I'm going to integrate this here, what I just found, right? So I need to take the integral, but when I integrate, right, I need to go from, because of here, okay, this right here, okay, I need this to be positive, so I'm going to go from -8 to 8. Now here's the thing. The trick here, I'm going to show you what I do, and then I'm going to show you that there is a different trick you can slightly do. So I'm going to do -8 to 8, 7 pi over 64, 64 minus d squared, and I'm doing it dz. And I'm going back here. I need to go back to z. Okay, so this is a z. Okay, you could do this from 0 to 8 and then just double the answer. I usually just deal with the negatives, but if you are like, I'm going to screw up those negatives, you could go from 0 to 8 and you could then double the answer. So just kind of, that's a option. So this is 7 pi over 64 and 64z minus 1/3 z to the third. I'm just integrating -8 to 8. So then I get 7 pi over 64, and then in here I get 64, 8 minus 1/3, 8 to the third, minus, and then in here 64 times -8 minus 1/3, -8 to the third. So this is where you can see the negatives are going to get kind of disgusting in here. I don't really care, but if you do, that's why you would do the whole doubling thing. So let's see here. I need my calculator, which is in here somewhere. Okay, so let's see here. So I have 64 times 8 minus, let's see here, minus 8 to the third divided by 3. Now what I'm going to do here is this is going to be the same thing, only it's going to be negative, so then I can just times this by 2, and you can see why that would work then there, and then I'm going to times this by 7. And of course you could work this all out if you don't trust my in my head algebra. Then turn this back into a fraction and add the pi, so 224 pi divided by 3. Okay, now they want us to do the same thing, but they want us to do it for this ellipsoid. So now we've got a little bit different one, so I'm going to start a new page here. So I have x squared over a squared, so we're going completely general, plus y squared over b squared plus z squared over c squared equals 1. So what we're going to do now is we're going to do the exact same thing, only we're going to do it for the general. So I want to move that z over so then I can be in terms of just my regular ellipse, and then I'm going to integrate. It's going to be lots of fun here. Okay, so x squared over a squared plus y squared over b squared minus the 1, so 1 minus z squared over c squared. Same process here, plus y squared over b squared. So this is c squared minus z squared over c squared. Now I'm going to divide by this. So now I'm going to get x squared over a squared times c squared minus z squared over c squared plus y squared. This is just keeping it c squared minus z squared over c squared, and this equals 1. So then so then my a and b, so then this here is going to be a over c radical c squared minus c squared, and this is b over c radical c squared minus c squared. So then when I go and I multiply them through here, per my formula, I have pi ac bc, and then I have my two c squareds minus z squareds squared because there's 2 of them. So this is going to simplify to, let's see here, I have ab pi over c squared times c squared minus z squared. Okay, so this is my first step, right? This is the area. Now I have to integrate it, and I'm going to integrate from negative c to c, ab pi over c squared minus z squared dz. Okay, because I'm in terms of z, which is what I wanted here. Now, remember, when I look at this, the only thing I'm integrating with is z. The rest of these are just constants. So I'm going to have ab pi over c squared, and then I'm going to have c squared z minus 1/3 z squared to the third now, from negative c to c. Okay, so now I'm going to put in, so I'm going to have ab pi over c squared. I'm going to keep this out front. So here I have c to the third minus 1/3 c to the third minus, okay, negative c to the third. That's going to be a negative, so then this is plus 1/3 c to the third. Okay, so what do I got here? I have AB pi over c squared. Okay, so right here, this is 3 over 3. So this is 2/3 c squared. 2/3 c squared. Sweet third. Oh, third. Okay, this is going to be 3 over 3 plus this. So this is going to be negative 2/3, but then with that, I'm going to add, change my signs, 2/3 c to the third. So this simplifies down to AB pi over c squared 4/3, because I'm adding them, c to the third. I don't know why I decided one parenthesis and one bracket, but why not? Okay, so then I have 4AB pi c to the third over c squared, and the 3 here. Don't want to lose it. Then all I got to do is simplify. So that's 1c is left, right? Because quotient rule of exponents. So then there is my answer. 4abc pi over 3. So let's come back here. So this is 4/3 abc pi. Okay, now what if a equals b equals c? So this is a sphere. Well then a equals b equals c means I have either a cubed, b cubed, or c cubed, which is the same as r cubed, which is the form volume for a sphere, because sphere is 4/3 pi r cubed. So it shows that that works. Okay, so you can see a little messy, but not too bad, right? Could be far, far worse.